Hello everyone. In this video, I'm going to explain you about shear stress distribution of T-section. So here is a T-section, 100 mm width and 100 mm depth and 20 mm thickness of the web and 20 mm thickness of the flange. So for this T-section beam, we have to calculate shear stress at the neutral axis and at the junction of the web and flange. Okay, so in the junctions we have to calculate the shear stress and at the from neutral axis. So first we have to calculate the neutral axis, and momentum of inertia about the horizontal neutral axis is given, that is 314.221 into 10 power 4 mm power 4. So first we have to calculate neutral axis. Okay, so given for shear force F equal to 50 kilonewtons, that is 50,000 newtons. And next, moment of inertia about the neutral axis is given. Moment of inertia about neutral axis is given, that is 314.221 into 10 power 4 mm power 4. Okay, so the neutral axis position, that is nothing but here T section is there, here the YY, I mean first we have to calculate neutral axis. For that we have to obtain, we know the position of center of gravity of the T section, that is this is the symmetrical position, that is YY axis. Okay, and hence the center of gravity of the section will be lie on YY axis. So first we have to find out Y bar. Y equal to distance of center of gravity of the section from the top of the flange. So here, from here we are going to calculate Y bar from top of the flange to downward neutral axis. So formula is A1Y1 plus A2Y2 by A1 plus A2. Okay, so A1 is nothing but area of the flange. I am considering this is as 1 and this web as 2. So A1 is nothing but area of the flange, this one, nothing but L into B. If we consider this as a rectangle, L into B, 100 into 20. So A1 100 into 20 into Y1. Y1 is nothing but centroid of that flange. So centroid of the flange is nothing but half of this flange, that is 20 by 2. 10. Okay, next A2Y2. So A2 is the web, and nothing but 20 into 80. 80 is nothing but this total depth is 100, and we need to know about this depth of the web. So 100 minus 20, 80. 20 into 80 is the area. Okay, and next Y2. Y2 is nothing but centroid. So into Y2 is 20 plus 80 by 2. Okay, from top of the flange we are calculating, so 20 plus half of this web. From here to here it is 80. Up to here it is 80. So we are going to calculate from top of the flange. So from here to here it is 20 and web portion is 80 by 2 because we are calculating web. So that's why I wrote 20 plus 80 by 2, that is Y2 divided by A1 plus A2. So A1 is 100 into 10 plus A2 is 10 into 90. Next, I'll tell you that how it is 10 and 90. So A1 is nothing but 100 and A2 is nothing but this one 100 into 10 into 90. So this 90 is nothing but, actually this web portion, it will include up to this mid portion. So mid portion is nothing but 20 by 2, that is 10. Okay, so 10 into 90. So I got, this one is 20 and this one is also 20. So I got 9600 by 2000 plus 1800. So I got the value 32.22. So this is the y bar value, centroid. Okay, so first we have to locate this one, nothing but top of the flange to up to here. This is the neutral axis, 32.22, and the remaining is 67.78. So this is the neutral axis. Okay, this is the neutral axis. Next we have to calculate shear stress distribution in flange. Distribution in flange. Okay, our formula is, in question he told that shear stress in the flange just at the junction of the flange and web is given by tau equal to F into A into y bar by I into B. Okay, so A value we know that 100 into 20, that is 2000 mm square. Next, y bar, this is y, not y bar, this is y, and y bar is 32.22, which is the y distance on top of the flange, 32.22. okay, so in this we have to taken from this because we are calculating the web portion. Okay, so this means from here to here it is 10. So 32.22 minus 10. Okay, after that width of the flange is given, that is 100 mm. So substitute all the values in this equation. So tau equal to F value 50,000, 2000 area, and y bar value 22.22 divided by momentum of inertia, which is given in question, momentum of inertia about the horizontal neutral axis, that is, I will show you, and B value is 100. This one, momentum of inertia about the horizontal neutral axis is 314.221. So I got the value 7.07 Newton per mm square. So after that, first we calculated in the flange, and next shear stress distribution in the web portion. So first we have to calculate junction of the web and flange will suddenly increases. So that is 7.07, which one we got the tau, into 100 by 20. Newton per mm square. The shear stress will be maximum at neutral axis. Why? Because here this condition is nothing but the shear stress in the web just at the junction of the web and flange will suddenly increases from 7.07 Newton meter square. That is nothing but 100 by 20. So 100 by 20 is nothing but this one. 100 by this 20. In this junction it will suddenly increase. That's why I wrote like this. Okay. So after that again we calculating tau equal to F into A into y bar by I into B. Okay. Here F value we know that. So A into y bar. So A into y bar we calculated. So A into y bar equal to moment of area of the flange about neutral axis plus moment of area of the web about neutral axis. So first moment of area of the flange about neutral axis, that is nothing but 20 into 100 into 32.22 minus 10. That is moment of area of the flange about neutral axis. That is 20 into 100. That is nothing but area 32.22 minus 10. This one. So we will get the moment of area of the flange about neutral axis. That is A and y bar plus moment of neutral axis, moment of area of the web about the neutral axis. This one is flange, and again we are going to calculate web 1. So 32.22 minus 10 into 22.22 by 2. Okay. So I got 49377.284 mm square. So I substituted all the values in this equation. F value 50,000 and A into y bar value this one. Okay. So after that (314.221), that is moment of inertia which is given in question, into 10 power 4 into 20 B value, thickness of the web. So I got 39.285 Newton per mm square. Okay. So now we are going to draw the shear stress distribution of the T section. I'll show you. So here in question he told that calculate the shear stress at the neutral axis and at the junction of the web and flange. So here is the junction. Okay, and it will slightly vary. That is, we got that 35.285. It will increase suddenly. 35.35. Sorry, yes, 35.35. Not 385. 35.35 I got. So here to here we're going to join this one, and here I told that it will increase suddenly in the junction portion. Okay, I hope you understood this. Sorry, from here to here it is 35.35. Sorry, so this is 35.35 and this one is tau max, that is maximum 39. We got it 39.285. So this is a final value 39.285 from here to here at junction portion, and it will increase, suddenly increase at, that is 35.35. I'll show you the values. So we calculated here shear stress distribution in the web. It increased suddenly 35.35, that is here. Okay, and this value is 7.07. and this one is from here to here 39.285. that is our ultimate value. Okay, thank you so much. Thanks for watching.